So this question is asking us to find all of the zeros for this polynomial. So we want to set the polynomial equal to 0 and then solve that equation. Now you could try to factor it because there's 4 terms, but there's nothing in common to all 4 terms. So again, if you cannot factor it, then you really are only left with the synthetic division method. And with the synthetic division method, we are going to have a starting 0 to plop down over here to get our 0 remainder. Now, the issue with this question is they don't give you any other information. They just say find all the zeros and that's it. So in order to get that starting 0, what we're going to have to do is either use the rational zeros theorem, which as we discussed is very tedious, or we can use our graphing calculator. So what you would do is you would go to your graphing calculator and you would type in the polynomial that they have given you. And you can use the second calc 0 feature, but probably the easiest way to do this is to hit the second button followed by the graph button. And right above the graph button is that table. And so when you hit the second table button, what you're looking for is where y is equal to 0, because that will give us our x-intercept or a 0 of the function. So the point of interest here is where y is equal to 0, and I see that the corresponding x value is 1. So that tells me that one of my zeros of this polynomial is x is equal to 1. So that's my starting point. I will go through synthetic division using the 0 that I found from the graphing calculator of 1, write out my coefficients, and then go through synthetic division. So we have 1, we bring down, 1 times 1 gives us 1, add vertically, -6, multiply diagonally to get 13 minus 6, so you get 7, multiply diagonally to get +7, add vertically to get 0. And again, this 0 remainder is our verification or double check that x is equal to 1 is in fact a 0 of the polynomial. Now, the whole point of this synthetic division process is we started with an x cubed polynomial, and now we're looking at an x squared polynomial. So hopefully we'll be able to deal with this quotient of x squared. So we have x squared minus 6x plus 7, and we're going to set that equal to 0. All right, so then we can do 2 methods here. We can either do the quadratic formula or factoring. And I always try factoring just in case it works out for me here. So if you look at the factors of 1 times 7, they have to sum up to give you -6. Now, you could change this to a -7 and a +1. But the problem is when you do that, you no longer get the +7 that you need. So you can try all day, but there isn't going to be a way to factor this using just our factorization methods. And so because of that, and because of the fact that we have an x squared, we are going to have to go into the quadratic formula. So we will take negative, our b is -6, plus or minus square root -6 squared minus 4 times a, which is 1, times our c, which is 7, all over our 2 times our a, which is 1. And then we go through our simplification. Do be super duper careful about your simplification here. So we have a 6 plus or minus. Remember that whatever is inside of the squared is always going to be a positive, so 36. And then we multiply all of these together. So negative is the only negative in sight, so that's going to give us a -28 all over 2. All right, so then we simplify here. So we have 6 plus or minus, so the 36, we're going to have a 8 left over 2. And then we simplify from here, looking at the square root and asking ourselves, okay, what inside of the square root can we take out? When we look at 8, we have a factor tree of 4 and 2, 2, 2, and 2. And so that tells us that we can take 1 copy of 2 out in front of the radical. So this will be 1 copy outside of the radical. And so we will have 6 plus or minus 2 square root of 2 all over 2. Now, to simplify this further, you then say to yourself, okay, from here I can take out a 2, so I'll have 3 plus or minus, and from here, I'm not really looking at the square root of 2, I'm looking at the coefficient. So this 2 divided by 2 would give us a 1, and that would be plus or minus square root of 2. So these are the other zeros. The other zeros will be 3 plus or minus the square root of 2. So altogether, we found initially a 0 of 1, and now we have our other zeros of 3 plus or minus square root of 2. So this question, we find the 0 using the quadratic, or using our second table, and then from there, our quotient is not able to factor, so we go through the quadratic formula to find the other zeros.